presenting is going to be Stephen. Yes, absolutely. And he is a software engineer leading Teleport Cloud's backend infrastructure team. His background is in Kubernetes, app platforms, open source developer tools, and supply chain security. As a former technical lead for VMware Tanzu, he founded the CNCF Cloud Native Buildpacks and has led 5 Cloud Foundry subprojects. Pretty busy guy, so take us away.
Hey everybody, can you hear me? Great, all right. So I'm going to talk about Teleport Cloud today. So Teleport Cloud, if you don't know, is a kind of highly available, globally available deployment of Teleport, really many instances of Teleport that's used to as a kind of hosted version of Teleport. So you don't have to run it yourself. You can rely on Teleport, the company, to provide that for you. So I think this talk will be especially useful to you if you are trying to decide between Teleport Cloud or self-hosting Teleport, or if you're using cloud and you're curious about how it works, or maybe you self-host Teleport, but you want to kind of scale up what your deployment looks like across many regions or anything like that. So hopefully you find it helpful. You've probably heard this so many times today already, but Teleport is an open source infrastructure access platform. It makes use of reverse tunneling, which we'll talk a lot about in this context, because that's how most of the resources connect to Teleport Cloud, to provide audited access to infrastructure, and that's like Kubernetes, SSH, DB, web, desktop, etc. We support all the resource types on cloud. So if you kind of dig into what one of those tunnel connections look like, and let's imagine you're connecting to a Kubernetes cluster, right? You might use kube control, but instead of connecting to Kubernetes directly, you connect to a Teleport proxy. And on the other end, a Teleport agent running in Kubernetes is also connected to that proxy, but that Kubernetes cluster isn't exposed to the internet. So it's making an egress connection to the same proxy that the kube control is. And then when you run kube control get pods, your connection goes through the proxy and through the encrypted tunnel into the Kubernetes cluster. And that's how we provide access without you having to expose Kubernetes. If you zoom out on the architecture a little bit more, there's another component called the auth server that kind of acts as a certificate authority for the whole thing, but it also it's like an authorization store with, that's where roles are stored. It handles audit logging. It receives logs from all of the kind of resources and stores them. And so if you think about Teleport in a self-hosted context, usually this is maybe you just have a single pod that's running auth and proxy together. Maybe you've split them, but it's usually deployed close to where the resources are in a private cluster, usually in a single region, maybe in a single AZ, right? It's often not a massive globally available deployment, but something smaller than that, although there are many different ways you can deploy Teleport yourself. And often it's deployed on Docker or Kubernetes. Teleport Cloud is really different. So Teleport Cloud is it's many instances of Teleport, one per customer. We run over 10,000 pods, over 100,000 reverse tunnels. If any of those tunnels are disconnected, any active connections going through them gets disrupted. So we really care about kind of stable ingress, making sure that we can update our infrastructure without disrupting customer access to anything. And finally, it's clusters that are deployed into 6 regions. It's a total of 7 Kubernetes clusters. And the way, kind of a difference between many self-hosted deployments and cloud deployments is that in cloud, an agent might be connected to a proxy in one region, and a client might connect to another proxy in another region, and those proxies are going to peer to provide connectivity so that you always get kind of the lowest latency connection possible. So the things we're going to try to answer here are, is Teleport right for your use case, and what can you learn from Teleport Cloud? So I've kind of broken this down into 3. The difference between self-hosted and cloud is that it's a multi-region HA deployment, and so I've kind of broken it down into 3 categories of things for kind of managing this. Ingress, which is how do we provide these highly available, ultra long-lived reverse tunnels that are up all the time that ideally never drop. How do we handle deploying, upgrading Teleport across many regions, without, creating disruption. And for, these 7 different Kubernetes clusters we have, how do we, handle container networking between all of those clusters that have to communicate in internal networks? So how to proxies reach auth servers, how do proxies talk to each other, and that's kind of a separate problem from ingress. So focusing on ingress first, some things we tried early on, and I just want to point these out as things you might think of that maybe you want to avoid in different cases. We tested out Anycast actually as a way to provide global routing so that we could have one static global IP address and not have to worry about DNS issues. There are some use cases with Anycast related to streaming video with long-lived TCP connections that we thought it's maybe worth a try because there are a lot of benefits. Some services that do longer-lived TCP connections are using it. But we found that for reverse tunnels, it's really not a great solution, as you might imagine, because having routing shift occasionally, drops tunnels and kind of degrades availability. So we didn't go with that. I really wouldn't recommend Anycast for kind of teleport at any scale. A lot of configurations of teleport AC use Nginx, not as a terminating load balancer, but as with TLS pass-through. And we didn't end up going with this for cloud because to make changes to that configuration, you end up with a lot of instances of Nginx that are managing old connections, which kind of inflates memory usage. It doesn't really support in-process configuration reloading. It supports Alpin routing, which Teleport uses to distinguish different protocols that are connecting to the same port, which is kind of a key feature that's important. So you could use this for your own self-hosted deployment. If Teleport's on your, you need to split Teleport and some other things, behind your own kind of load balancer, but it didn't work very well for cloud. The recommendation I'd have if you're self-hosting is probably just to give Teleport a dedicated load balancer. I think you're always going to avoid the most issues that way. But in our case, we put many instances of Teleport, behind one port. This is what we did do. So this is how cloud, kind of solved our ingress problem. We use Route 53 latency records and the external DNS operator. So this is kind of like a GeoDNS type setup where we have external DNS running in our clusters, and they're reaching into Route 53 and telling Route 53 what all the regional IPs are that of regional load balancers that clients in that region should connect to. As I said, we use NLBs. We use stateless network load balancers. We found that when, in this case we're using AWS, we found that when they do infrastructure rollouts, we're not really affected by their activity and when network load balancers are updated. And finally, for the ingress stack inside of our clusters, instead of Nginx, we went with Envoy. And so we use Envoy Proxy. We manage Envoy Proxy through kind of a newer project called Envoy Gateway. That's a set of Kubernetes controllers for managing Envoy, and through the new Kubernetes Gateway API resources. A little carefully because they're still kind of early as well. And finally, we have what I think is a clever strategy for dealing with zero downtime deployments, where we use some features of Kubernetes deployments, which I'll talk about in a second, like min-ready seconds, to provide kind of guaranteed availability for tunnel connections. And you'll see what that looks like soon. So just to give you a sense, and this is going to get kind of technical, I apologize, but just to give you a sense of what this looks like, so imagine you're a client, you're running kube control again, and you're connecting to a Kubernetes cluster, which is an agent running in a Kubernetes pod. If you look at the Teleport cloud infrastructure that we'd have deployed, say you're connecting to US East 1 and you're connecting to an agent in AP Southeast 1. So you'd connect, so you'd have the Kubernetes agent open up a reverse tunnel to the Teleport proxies running in AP Southeast 1, and you'd make a connection to your local proxy. Again, both the agent and the client are connecting to the same domain name, but they result to different load balancer addresses in the different regions, and your client connection hits pods in your closest region, which peer through AWS infrastructure to pods in AP Southeast 1, and then that connects to your agent. So if I kind of take out the auth piece of this and we just focus on that ingress piece, right? What our ingress stack looks like is, it's like I described before, you have external DNS running in each of the clusters. You have NLBs sitting, as load balancers in front of the proxies in each of the regions, and then external DNS gets the NLB IPs, creates latency records for them, and then Route 53 serves the IP address of the closest NLB, regional NLB, depending on where you're connecting from. And so how do we do zero downtime on top of this infrastructure? So again, kind of coming back to that same diagram, as I mentioned, we run Envoy. So we're running Envoy inside of each cluster, behind the load balancers, behind the AWS NLBs. When we want to do an upgrade of Teleport, so when we want to roll out a new version of Teleport without disrupting any kind of, without reducing availability of the platform, so what we do is we spin up new proxy pods in each region. We keep the old proxy pods running, and we use a feature of Kubernetes called min-ready seconds that lets you basically keep 2 generations of the same application running and accepting new connections for kind of as long as you'd like. So, and for a small customer, that might be about 2 minutes, where you have tunnels going to both generations of proxies established from the agent side and the customer infrastructure. We use our own custom controllers to flip service back and forth so that we can point Envoy, we can point new connections at the new set of pods, new client connections, but allow both sets of the old and new generations of proxies to receive tunnel connections at the same time. So that's kind of a cool trick, I thought. And then, finally, after the deploy is finished and all the connections have drained off, after a termination grace period, we shut down the old proxy pods. So that's kind of what our ingress stack looks like. Next, I'll talk about deployment. So how do we do kind of coordinated rollouts of Teleport across many regional clusters? And so for most folks, I'd recommend GitOps, right? That's kind of the obvious solution. You're deploying some stuff to Kubernetes, you put your deployments in a Git repo, and kind of go from there. In the case of cloud, in order to do the zero downtime deployment we wanted to do with the kind of tunneling logic, we needed our own controller anyways. And so we looked at, can we store the custom resource that manages the different Teleport objects on the cluster in Git. And we, I think for a self-hosted deployment, this could work very well, even if you have your own controller. In the case of cloud, to do a big multi-region deployment, we wanted to be able to kind of get feedback from different regions to make decisions about how we're going to, progress with the rollout or roll back or whatever we need to do. And so that kind of unidirectionalness of GitOps was not as helpful for us. Maybe with Argo and some other tools, it'd be doable, but that's not the direction we went. For cloud, we also wanted to store all the data in Postgres instead of storing it in Git. We don't want to take a bunch of customer data and check it into a Git repo. So we wanted to make RDS our kind of source of truth for the whole platform. And so that's another reason we didn't kind of go with GitOps. There's another idea we thought of that we tried for a little bit where we had one custom resource is a Kubernetes custom resource deployed into our management plane cluster, and then controllers in a bunch of different regions, regional clusters, all reconciling against that. And I really wouldn't recommend this for anything. It didn't work very well. It kind of creates a single point of failure with, if the management cluster goes down, then everything is trying to reconcile and it can't. Usually you want to write back status of things to your custom resources, and it didn't work very well with a whole bunch of regions. KubeFed, we really like KubeFed as a model for kind of doing a big multi-cluster, complex deployment that involved controllers, but the project isn't really active anymore. And so we built our own thing called Sync Controller, which is open source. And you could use this yourself if you wanted to, build some controllers around your Teleport instances in order to create a multi-region deployment. But essentially what we have is a management plane in our management cluster with a single CR you create that kicks off the whole process, and it creates different CRs called teleport deployment CRs for every region. And then this controller called Sync Controller looks at those CRs and automatically provisions infrastructure into regional clusters and then keeps those regional clusters up to date. The way Sync Controller works, and I think this is kind of a novel tool for managing regional state when you have many clusters, separate Kubernetes clusters deployed into different regions, is that it'll let a kind of management controller create custom resources, create their spec, their kind of thing that defines them. It'll make sure that's continuously copied over to the regional clusters, and then as they're processed regionally, it'll upload status back to the management cluster. And so in the case of Teleport Cloud, the way we use this is with those teleport deployments you saw earlier, but our management plane is also doing the centralized work like creating DynamoDB tables and Athena for audit logging and some other things too. One kind of cool thing we did, I mentioned that we store all the customer data that goes into the cluster. The source of truth for that lives in Postgres. We actually store that as a Kubernetes object in Postgres in JSON-B. And then we apply the same open API validations that Kubernetes uses to validate its own resources back in the portal, so that we can validate really early and make sure that if someone messes up when they're onboarding a customer or whatever, we can reject that early in the process before it hits the cluster. And so that's how we do deployment. I'll talk just for a couple minutes about container networking. And so, how do we allow proxies to peer with each other? How do we allow proxies to talk to the auth server? So we use Cilium Global Services, which is Cilium is like a container networking solution for Kubernetes. Cilium Global Services is a kind of extension to that allows you to do cross-cluster container networking. We found that the best configuration for that was with a dedicated etcd. If you look at it, there are a bunch of different configuration options, but that's what we settled on as kind of what seemed to be the most stable now. And so what this lets us do is, if you look at a deployment that's in, let's pick two regions like US West 2 and US East 1, and focus on the services. Those are kind of Kubernetes representation of an IP address that you can connect to that might route to deployments. In a region that's running auth, that auth service would point to auth pods, but in a region that's not running auth, it still has a copy of that auth service. It just automatically gets directed by Cilium Global Services to the region that's running the auth server that I talked about at the beginning of the talk. In some regions, if a customer doesn't have any resources in that region, we also have the option of not running anything in there and just using the container networking infrastructure to provide really local connectivity solution for anything that happens to be in that area at a time, but that all gets redirected to the next closest region, which is a cool feature. And so that is my kind of overview of Teleport Cloud architecture. And again, I talked about ingress, how we manage these ultra long-lived reverse tunnels. I talked about deployment, so how do we manage this, all this infrastructure across many regions, and container networking, how we handle, we let auth and proxy servers talk to each other within the cloud platform. A lot of this is open source. So as I mentioned, we just open source sync controller. So if you have some things you want to do that are multi-region on Kubernetes, you can check it out. It doesn't provide the teleport management pieces, but I think it's a really useful tool for kind of managing multi-region, multi-cluster Kubernetes deployments. We also have a fork of Envoy Gateway that adds some extra stuff around TLS routing and Alpine routing that we put in. And of course, Teleport itself is open source as well. And that's all I got today. So thanks, everybody. The rest of my team is here if you have questions. Carson is sick today, but Dave Bosley and Bernard are here as well. So thank you.
Yeah, are there any questions for Stephen while we have him?
So we're thinking about the SaaS option, but we're a little bit hesitant because of the proxy are located in cloud. And I just wondering, can we deploy those on premise?
So there's a mode called trusted cluster mode. We may not support that on cloud right now. If you have that use case, definitely reach out and we can talk about different ways we could deploy teleport that might meet your use case there. Right now, the answer is no. Currently we run proxies, entirely in the cloud platform, and your resources connect to those proxies. For some protocols like SSH, like SSH in the common configuration for cloud, the connection is end-to-end encrypted, so that there's not the auditing happens at the agent level, and so that the proxy runs in cloud isn't kind of a concern in that sense. Is there a specific reason you're worried about the proxies running in the cloud platform?
Yeah, because our network, right? So we worried our on-premise or even our cloud targets, they have to go through internal network to connect your proxy.
So in the configuration I talked about here, you can have your resources that are behind your firewall with no ports exposed on your firewall, make egress connections to the proxy that just remain open all the time. And so it kind of provides, without having to configure your load balancers to expose your resources to the cloud platform, we can still provide access to the resources that sit behind your firewall without having to do those reconfigurations. Does that make sense?
Right. Well, we are more worried about the performance instead of say the firewall stuff. Yeah.
Okay, so you're worried about like latency,
Yeah,
with,
latency,
routing through those tunnels, if
Yeah,
that makes sense.
too many hops.
Yeah, we do, like I kind of showed in the presentation, we have proxies deployed in every region, so that usually each connection you're making is relatively close, and the long distance connections are only made through the cloud platform between AWS infrastructure. Have you tried it out? Is the experience here?
No, we have not
seeing
tried it yet. So,
maybe give it a try and see if it meets your performance needs. But also happy to chat if you or talk more afterwards if you want to kind of dig into more details.
well, another question, so you support multi-region cloud, but actually can one customer have multiple instances across regions?
So all customers have proxies deployed into all regions, and so it's globally available. It doesn't matter. The auth server right now is just in US West 2, but that's cached at every level, so it doesn't affect it doesn't increase the latency to make new connections or for existing connections.
Thank you.
Yeah.
Other questions? Did you? All right. Well, thank you so much for your. Oh, there's one. Oh, sorry. Oh, no clapping. No clapping.
So you said that the auth service is cached. So is that the backend storage that is cached, or just the service, because that is stateless, right?
Yeah, so the proxies don't have a persistent cache, but they have an in-memory cache that holds a lot of what the auth server holds in its backend to do authorization. So for instance, roles are cached at the proxy level so that every connection doesn't require connecting back to auth in order to make the connection fast, if that makes sense. Those roles are also cached in the agents so that they can make authorization decisions too.
So we can have these same for our self-hosted also. It's the same set of options that are there in the configuration.
Yeah, of course. You can basically create cloud and self-hosted if you want to. It's just a lot of work. We think we do a pretty good job of it.
Other questions? All right. I think that's it. Thank you so much, Stephen.